Hello, 6th grade! Today we're going to talk about powers of 10 and scientific notation. Some of this will be new to you, some of it might not be new. I do have an outline for you. I posted it in Google Classroom and you can print it from there. If you don't have a printer or you don't want to print it, you can take notes by yourself. Or you can wait till you come back to school and get a hard copy from me and then fill in the blanks later. The first page that we are doing is not in your outline, so you can just follow along with what we're doing here. It is from your book on page 125. It's a table and it's having us explore the relationship between multiplying 10 by itself a whole bunch of times and the exponents in exponential form. So the top table says multiply and we have 10, and then 10 times 10, and 10 times 10 times 10, and 10 times 10 times 10 times 10, and so on. The second row is the answer to those problems. 10 is just 10. 10 times 10 is 100. 10 times 10 times 10 is 1,000, and then 10,000 and 100,000. The third row asks us to count the number of zeros. There's 1 0 in 10, there's 2 zeros in 100, 3 in 1,000, and then 4, and then 5. And the fourth row asks us to write the original problem in exponential form. So 10 is just 10 to the first power. 10 times 10 is 10 to the second power. And then we have 10 to the third, 10 to the fourth, and 10 to the fifth. Notice that the exponent for each of these matches the number of zeros in the problem. So when we did 10 times 10 times 10 times 10 and we got 10,000, which has 4 zeros, and is 10 to the fourth, the 4 exponent tells us how many zeros there are in the problem. And this is very helpful for what we're doing today. If we look at this table down here, we can see what happens when we multiply these powers of 10 by other numbers. In elementary school, you probably learned that if you multiply a number, say 2, times a 1 with a bunch of zeros after it, you just write the number and then that many zeros. So 53 times 1,000 would be a 53 with 3 zeros, or 53,000. But that does not work when you have decimal places in your number, like in this second column. 7.2 times 10,000 is not 7.2 with 4 zeros after it, because that hasn't actually changed the value. This is still 7 2/10. So we need another way to work with this. Well, if you look, they've already told us the answer. 7.2 times 10,000 is 72,000. The decimal point started here. And there are 1, 2, 3, 4 zeros. Decimal point started here, and it ends up 1, 2, 3, 4 zeros to the right. So that's what we use for this when there are decimal places. We don't just put zeros on the end. We actually move the decimal point. And that's what you're doing in these problems also. The decimal point is after the 53, so we move it 1, 2, 3 places, and we get 53,000. So in the third problem, 3 5/10 times 1,000, it would be 3 5/10, but the decimal point is here and we move it 1, 2, 3 places. So we end up with 3,500. We're going to skip the next one for now and go over to this one, 36 8/10 times 1,000,000,000. So we have 9 zeros, and the decimal point starts here, so we need to move 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. So 36, and then we have 8 is 1 space, 2, 3, 4, 5, 6, 7, 8, 9 spaces that the decimal point moved. We get 36,800,000,000. So let's take that back to this problem. We could write 4,800,000 as 4.8 times a 1 with 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6. So it would be 4 8/10 times 1,000,000. And the last one, 2 and 79 hundredths times 100. We're going to move the decimal point 2 places, so it's 279. All right. Next, this part is in your outline. We're going to start with multiplying by a power of 10, which is essentially what we just did. To do that, you have to move the decimal point to the right as many places as there are zeros. So in example 1, part A, our decimal point starts right here, and we have 1, 2, 3, 4 zeros, so we need to move 1, 2, 3, 4 places. And we end up with 6249 and 2 extra zeros, so 624,900. In part B, you can do that one in your head. It's 4 times 100 or 400. If you want to see how it relates to the rule that we have up here, the decimal point is after the 4 and we move 2 places. All right, I want you to do part C by yourself. You should have gotten 6,891 and 2/10 as your answer, because there are 3 zeros in the problem in 1,000, so we move the decimal point 3 places to the right, and it ends up between the 1 and the 2. Now we're going to take that one step further, and instead of just multiplying by a power of 10 as a 1 with a whole bunch of zeros after it, we're going to multiply it as a power of 10 written in exponential form. Exponential means it has an exponent with it. And we do this basically the same way as we just did the last ones. Move the decimal point to the right as many places as the exponent. This time we're looking at the exponent instead of counting zeros. So in example 2, part A, we have 42 and 68 hundredths times 10 to the 3rd power. So the decimal point will move 3 places. 42,680. 42,680. Part B is 10 to the 2nd power. So we're going to move it 2 places, and it becomes 129 thousandths. In part C, we have a whole number. That means the decimal point is after the 2. But we still have to move it 6 places. So 1, 2, 3, 4, 5, 6. This time we're actually going to add 6 zeros. And we get 42 million as our answer. And finally, part D, 8.1 times 10 to the 1st, so it moves 1 place, and we get 81 as the answer. I'm going to give you a couple problems that are not on your outline to do. You can answer them as they come up on the screen. All right, so now we get to the meat of the lesson. Scientific notation, what is it? I think maybe you've talked about it in science class, so this might not be new, but if you haven't, now you'll know it, so that when you do talk about it in science class, you understand. Standard form is the way we normally write numbers, so 83 million. Scientific notation is a way to write really big or really small numbers. So instead of 83,000,000, we can say 8.3 times 10 to the 7th power. For 83 million, that doesn't do a whole lot. But if you had a number that was, say, 268 with 50 zeros after it, you really would not want to write all those zeros. It would be much better to write 2.68 times 10 to the 52nd power. That's a lot easier to read and to write. This also works for really, really small numbers. We're not going to talk about them this year, but I'll show you what I mean. So if we have this tiny, tiny number, this is the same as 4.7 times 10 to the negative 1, 2, 3, 4, 5, 6 to the negative 6th power. You'll learn about those next year in pre-algebra. One of the nice things about scientific notation is that it makes it easy to work with these numbers. You can add, subtract, multiply, and divide them much easier than if they were in their original form. You'll learn about that when you get to Algebra 1. So before we can convert them, you need to know how to identify if a number is written in scientific notation. There are two things you need to look for. First of all, the decimal point has to be after the first non-zero digit. That means the number is between 1 and 10. It can be equal to 1, but it cannot be equal to 10. So the first digit cannot be 0, and you can't have 2 digits before the decimal point. And second, it has to be multiplied by a power of 10 written in exponential form. So multiplied by a power of 10 written in exponential form. Like we have up here, times 10 to the 52nd power. Example 3 asks us to tell if a number is written in scientific notation, and if not, explain why not. When we look for this, we're looking for a couple different things. We check the first number first. Is it between 1 and 10? Yes, it is. Is it multiplication? Yes, it is. Is it a power of 10? Yes, it is. And is it written with an exponent? Yes. So this one is written in scientific notation. Part B, however, is not. This number is between 1 and 10, but this number is not written with an exponent. So the answer for this one is no. 100,000 should be 10 to the 5th power. In part C, actually I want you to do part C and part D by yourself. Are they scientific notation? And if not, why not? For part C, you should have gotten no, because the decimal point is after a 0. And we can't have the decimal point after 0 because this number is not greater than 1. In part D, your answer would be no, because it's not times a power of 10, it's times a power of 12. 12 needs to be 10 in order for it to be scientific notation. All right, now we get to the fun part, writing numbers in scientific notation. The first thing that you have to do is make sure the first part is in the right form. So write the number with the decimal point after the first non-zero digit. So in example 4a, we have 58,200 and we need to write it in scientific notation. So we're going to write 5.82. You can write the zeros at the end, but you don't need to. We actually have scientific notation so that you don't have to write those zeros. The second part is the easiest part. You just write times 10. Part 2 is done. All right, then the next thing that you have to do is count the number of places the decimal point moved. So it started out after this last 0, and it moved 1, 2, 3, 4 places. That number becomes the exponent. So step 4, write that number as the exponent. So our answer for this problem is 5.82 times 10 to the 4th power. All right, we're going to do B and C together, and then I'll let you do D and another one on your own. Part B, the first thing that we do is write the decimal point after the first non-zero digit, so 8.4. And then we write times 10. And then we count how far did it move? 1, 2, 3, 4, 5, 6, 7, 8 places. So 8.4 times 10 to the 8th power. In part C, we write 1.261. And we see, and then times 10. And we see that the decimal point only moved one place, so it's 10 to the first power. All right, I want you to do part D and another problem by yourself. You can write your answer for D on your paper if you want, but you also need to write it in the box that I give you. All right, so part D, you should have gotten 1.103 times 10 to the 9th power. The last thing we need to do is learn how to change from scientific notation to standard form. And this we've actually already done. We did it when we were multiplying by powers of 10. To change a number from scientific notation to standard form, follow the steps for multiplying by a power of 10 written in exponential form. So example 5, part A. 3.6 times 10 to the 3rd power. We're going to look at that exponent. It tells us the decimal point has to move 1, 2, 3 places to the right. So it becomes 3,600. In part B, the exponent is 7, so the decimal point has to move 7 places. So it's 2041, and then we need 4 extra zeros after it. So it becomes 20,410,000. I want you to do C and D by yourself. For part C, you should get 9 billion. The decimal point starts after the 9, and it has to move 9 places. For part D, you should get 6,310,000. All right, well, that is the lesson for today. Your homework for tonight is from the book. Since most of you probably do not have your math books at home, I have posted a picture of that page on Google Classroom, so you can find the problems there. I want you to answer them on a piece of paper and bring it with you to class the next time that we have class. Thank you very much.